Hello, everyone. So we're going to get started today with the warm-up. As usual, join a table group in Discord. Otherwise, I'll put you in a breakout room if you prefer. And in the Zoom chat, I want you to answer the following 3 questions. Well, not 3 questions, but I just want you to find the following 3 things. Mr. Hoof got his parachute, so he's falling from a height of 300 meters in the sky. I have a mass of 50 kilograms and a total of 2,500 joules of kinetic energy. Find his potential total energy and velocity. So you can work on finding those for now. What I'm going to do on the board right now is I'm going to write out our strategy for figuring out these concepts, these ideas. So what I'm going to do is I'm going to write down this strategy, the guess strategy. So what I first want you to do is I want you to first figure out these, the things that we're given. So in the Zoom chat, what I want you to do is I want you to write down, I want you to type in what our mass is, what our height is, what our kinetic energy is, and what G is. So put this in the chat. Let's see if we can get some answers in. In the chat, I want you to write down what the mass is, our height, our kinetic energy, and gravity for this problem. Let's see if we got what, 90 people in here right now. So can we get 5 or 6 answers? 5 or 6 answers in here? What's our mass in this problem? What's our height in this problem? What's our kinetic energy? And what's G? So again, I have a mass of 50 kilograms. Well, I start off with that. Let's see what we can figure out. I want you to write this in the chat. Print the equations.
Never mind, I think I got them.
Hold on, let me switch to view here. Okay, so you should be able to see some on the board here. You should be able to see our strategy, our mass, height, and gravity. You can see some equations. So let's see if we can start filling this out. Right now in the chat, I just want you to write down what our mass is, what our height is, what our kinetic energy, what our G is. We're just practicing identifying the key conceptual ideas that were given to us. So I want to see some answers in the chat for the first one. I want to see what our mass is, what our height is, what our G is, and what our kinetic energy is. All right, these are given to us. Let's see if we can get some answers. Let's see if we get 5 people to respond here. We don't need to find our potential energy yet, our total energy yet, velocity. Those are some bigger, harder things to do. Right now, I just want us to try to just figure out what is given to us. So let's get some answers in here. Let's get some answers in here. All you have to do is you just have to read the problem and see if you can figure out what our mass is, our height is, gravity, kinetic energy. We got James a little ahead of it, who's a little ahead of us. That's good work. But we don't need to go that far yet. Sebastian, great job, Sebastian. So Sebastian who's identified our mass for us. But I don't want Sebastian to be the only one who's participating. Let's see if we can get some more answers here. Now all we're doing is we're just looking at a problem. Got a Mr. U, I've got a parachute falling from a height of 300. I just want us to identify our mass, our height, our kinetic energy, and what G is. Let's get some more answers in here. We got Arvid, great contribution. We got Mariano, we got Alec, great job. We got James, good job, James. We got Saya, good job, Saya. Can we get a couple more answers in here? And then we'll start working through this. So, all right, here's how we're going to start this. The first thing we want to do is we're just going to want to figure out what we know for each one. So in our problem, what I've told you that my mass is 50 kilograms. So 50 kilograms, it's only like 110 pounds. I haven't started lifting in this problem yet, so I'm pretty not quite there yet. My height, so I'm skydiving from a height of 300 meters in the sky. My kinetic energy is 2,500 or 25,000? 2,500 joules of kinetic energy. And gravity is 10 meters per second squared. This is very important. I want you to remember this. This is always the same. I don't want you to forget it. Every time you see in a problem where it says MGH, or every time I ask you what G is, I want you to be able to say 10. So if I say, hey, how much money do you have? I don't want you to say I have $10. I want you to say I have G dollars, right? If someone asks you how old you are and you say 10, I want you to say you're G years old. So remember that 10 and G are very, very, very important. Okay, so our next step here is we want to identify what we're trying to find. So in the chat here, what I just want you to do is I want you to tell me what we're trying to find. So let's see if we can get some answers here. What are the 3 quantities we're trying to find this from? Can we get some answers? We've got Malia. Oh, we've got so many people who've already started figuring this out. Great work. Great work, all of you. Well, we're just slowing down a little bit so that way everyone can clearly see how we're doing this. So we've got James in here. James has done a great job of identifying what we're trying to find. So what we're trying to find here is we're trying to find our potential energy, our total energy, and our velocity. Okay, great work. So the next thing we want to use is we're going to figure out which equations we want to use. So I'm just going to do this step for us, just because it's a little hard to type in the chat. So what I'm going to do is I'm going to tell you, okay, the equation for potential energy is mgh. The equation for height, the equation for total energy, well, the equation for kinetic energy, this is the one that we want to use, is 1/2 mv squared. And then our equation for our total energy is our potential plus our kinetic. So what I'm going to do is I want to give you, I know some of you have already been so good about getting started, but what I want you to take a minute, I just want you to try to substitute some stuff in and see if we can figure out our velocity. So we're just taking this a little slow, just so that way we can give everyone a chance to see what we're doing here. We've got Viviana telling us that G is always 10 meters per second. So good question. So what we got here is we got a lot of people who are really on top of things. We're really able to figure out our velocities and stuff. We're just slowing it down a little bit. What I want you to do is I want you to take a minute to substitute in the things we know into our equations here, and I want you to plug them into here. I know we've already had a bunch of people who have already started answering it. If a couple people can put in their like how they substituted stuff into the chat, I think that'd be really helpful for everyone as well. Simple like how did you plug in stuff for potential energy? I would love to see a couple of answers in the chat. That way everyone can sort of see how we're doing this. I need to get a little bit more practice. So if someone in the chat, if they can type in how they substituted in for potential energy, that would be really helpful for everyone, just to see how people are doing this. We are. Ooh, great work, James. James has done a good job. Does someone want to show us how we substituted kinetic energy? How they substituted stuff for kinetic energy? Great work. Mariana doing great work again. So what I'm going to do is I'm going to write down what James and Mariana said. They had some really good answers for us. So what James plugged in here is he knows that we're trying to find our potential energy. So when he knows that we have our mass, our gravity, and our height. So what James did here is he just plugged in our potential energy, which is what we're trying to find, is equal to our mass times our gravity times our height, 300. Great work, James. And then Mariana here, Mariana's done a great job of figuring out our kinetic energy. So Mariana knows that our kinetic energy is 2,500. If you're wondering where we got that, it was given to us in the problem, which is what we got earlier. And we know that by plugging into this equation, we can plug in 1/2 times our m, 300. So again, our mass is 50. Our mass was given to us up in here. And we know that we're trying to find our velocity, so we don't know that because we don't know our velocity. Okay, so we'll do a little bit of algebra here. So our potential energy, we multiply this out, 150,000 joules. This is very important. These units are very important. I don't want you to forget them. Energy is always measured in joules. Our kinetic energy is, what was it? Our kinetic energy, we already know. We were trying to find our total energy. So to find our total energy, what we do is we plug in our kinetic energy, potential energy, 150,000, plus our kinetic energy, which is given to us. So our total energy is 152,500. Okay.
What's the velocity?
What's the velocity? Perfect question. So we don't know our velocity. This is what we're actually trying to find. So what I'm going to do here is I'm going to show us how we find velocity. Because velocity, this requires the most algebra and it can be kind of tricky. So what I'm going to do is I'm just going to slow it down for everyone. We're going to do a nice, comfortable pace. So what I'm first going to do right now is I'm first going to take down what we substituted here. So what we first did for the kinetic energy is we identified that we want to find our velocity. And the best way to find our velocity is to use our kinetic energy equation, right? If you're ever wondering, okay, I need to find velocity, I don't know what equation I want to use, what I recommend is looking at the equations we have on the board and think which one has velocity. And the only equation that has velocity is this kinetic energy one. So we took this kinetic energy one, we wrote it down here, and then all we did here is we just added in the stuff we know. So we know our kinetic energy was 2,500, we know our mass, we don't know our velocity. So what I'm gonna do on the side here is I'm gonna show us how to do this, a little bit of algebra. 2,500 is equal to 1/2 times m times 50 times v squared. So first thing we do is we're gonna combine like terms. So we're gonna multiply this out. So this is 1/2 times 50 is 25. So 2,500 is equal to 25 times v squared. Then we're gonna do this, next thing we're gonna do is we're gonna get rid of this 25. So we're gonna divide both sides by 25. 100 is equal to v squared. 2,500 divided by 25 is 100. And then what we're gonna do is to get rid of the squared, we're gonna square root both sides. And we're gonna get that v is 10 meters per second. Does anyone have any questions on how we did that? I know that finding velocity can be the trickiest thing, so I do want to make sure that I'm answering any questions. Please don't be shy to ask any questions. I think chances are if you have a question that someone else has the same question. So please don't be afraid to ask any questions. Okay, so here's what we're going to do. So here's what we're going to do today. So the first thing I want you to do is I want you to, so we just entered a warm-up. What I want you to do is I want you to submit every single part of Roller Coaster Tycoon. Don't submit part 5 if you already started. I want you to submit parts 1, parts 2, parts 3, and part 4, even if you are not finished. If you did not even started it, I still want you to just submit a blank document. I want you to submit every single thing you have. I'm not grading these yet if you're not finished. For me, I just need to know where you are at. This is very important for me because right now on Canvas, I have a lot of empty spots in my gradebook, and that means I just have no idea where you are in terms of the assignments. So I want to make sure that I'm able to help you when I can. So that's what I'm going to do for the next 5 minutes or so. I'm going to give you 5 minutes. I want you to submit every single part into Canvas, and even if you haven't started yet, that's fine. I want you to submit every single one. When I get into my gradebook, I don't want to see any blanks. I want to see at least a submission from every single person. So we're going to take the next 5 minutes to do that. If you have any questions about submitting stuff, just let me know.
Was this for asynchronous yesterday?
Sorry?
Was this for asynchronous yesterday?
This is not for asynchronous. I already took attendance for that. This is just for me personally to see where you are. So yeah, take the next 4 minutes, 5 minutes to do this. Submit every single thing. And I'm gonna be looking through my gradebook to see who hasn't submitted stuff yet. If you already submitted stuff, that's great. If you have already submitted stuff, you can just keep working on Roller Coaster Tycoon Part 4, and then I'll do a bit more introduction to that when everyone's able to submit their stuff. So let's just take a minute to submit our stuff. Don't worry, I'm not going to grade them if you're not done. I just need to see where everyone is because I'm a little unsure if I'm moving too fast or moving too slow.
So you wanted us to resubmit parts 1 through 4, correct? Is that what you
submit parts 1 through 4. Yeah, if you're not done, that's totally fine. I'm not going to grade them. I just want to see where everyone is at.
do we turn in all parts or just for today? Because I saw that 3 was due on Monday, I think.
Yeah, so you submit every single part today. I'm not gonna grade them if you haven't finished them. Just submit everything you have. I just need to see where people are at. I just need to see if I'm moving fast or if I'm moving slow. So yeah, submit everything.
Do you want to resubmit them even if they're already submitted?
If you already submitted, don't worry about resubmitting them.
Okay. I was doing
Yeah,
it.
this is for me. This is just for the people who have a lot of blank spaces in the gradebook. For me, I don't really know where you are. I don't know if you're need a little bit of help or if you finished everything, you just gotta submit them. So I just want to see if we can get a chance to give people a chance to have people submit stuff. If you're just listening to me and you're like, I don't want to submit stuff, please do submit stuff. I really do need to see where people are. Okay, so while people are still submitting stuff, I'm gonna go start going over what we need to finish for today. So for today, what we're gonna do is we're gonna pick up where we left off on Tuesday. We're gonna keep working on these initial calculations. So if you remember, I added a bunch of practice questions. I fixed a couple of issues I had. So what we're gonna do is we're gonna work these practice questions. Hopefully, if we have time, I'll try to go through a couple of them on the board so you can see what we're doing. So I do want to give everyone a chance to keep working through this, work through the practice questions, and then work through the project questions. And if you have questions, let me know. If you've already finished everything in part 4, I want you to start part 5. I won't introduce part 5 as formally until next week, but you can get started with part 5. It should be, for the most part, self-explanatory.
What is part 5?
Part 5 is where you're going to start looking at. You're going to start analyzing. Do some basic analysis on whether or not your roller coaster is actually going to work. Yeah, very important. But it's mostly going to be written stuff. We won't do the math behind it until much further from now. Does anyone have questions what we're doing right now? So right now what we're doing is we are finishing up part 4, the initial calculations. It's on Canvas. And if you finish part 4, I want you to start part 5. Okay, if you have any questions, I'm going to let you get to it, and then I'm going to start contacting people who have not submitted stuff yet.
Mr. H, I had a question on, I'm about to turn in part 3, and I was just wondering, because we're supposed to say how all the energy like goes into the roller coaster, and I can't figure out how chemical energy is displayed.
Okay, I'll try. I'll see if I can help you answer that. But just submit it for now, and then you can resubmit it when you finish it.
Okay, thank you.
On the flow chart, oh, is the flow chart up on your screen?
You mean for question 3, for part 3?
Yeah.
It's not on the screen right now.
I was wondering how you get chemical in the beginning.
So in that flow chart, in that example, that was just an example. It's not. It doesn't. Your flow chart may not start with chemical. It's up. It's up to you. That was just an example to show you what a flow chart might look like.
Oh, okay.
Yeah.
For question 3 on part 4, how do you find the velocity if it doesn't give you the kinetic energy? We only need to do the practice problems, right? Not the project ones.
So when you finish your practice questions, start working on the project questions.
Okay.
Yeah. So we are out of time. It's 11:20. So here is what's going to happen. So your homework for the weekend is, so if you finish part 4, you don't have any other homework. If you haven't finished part 4 yet, I just want you to try to do as much as you can with part, whatever parts, part 2, part 3, whatever you can, and see if you can catch up a little bit. I've already reached out to some of you in terms of office hours. Please, if you haven't started part 4 yet, please come to my office hours today, or at least email me and see if we can schedule some other time over the weekend. So I am willing to commit some weekend time to try to help you guys come along, because I don't want anyone to fall behind. Hopefully I got a chance to see where everyone's progress is, but I'll try to reach out to you otherwise. Other than that, you're free to go. Thank you all for joining me today. And please see if you can come to my office hours, or at least talk to me and see what we can do over the weekend. Otherwise, have a nice day, and I'll see y'all later, over next week or something.
Bye. Thank you.
Bye.
Thank
Thank you. Bye-bye.
Thank you.
Oh, what is the maximum velocity again?
The maximum velocity of so which question is this?
I'm on the project questions, and I'm
Okay.
on question 3 right now.
So are you asking when does it have its maximum velocity? Or
What was that?
Are you asking when it has its maximum velocity, or are you asking
Yeah.
what? Okay, so
Yeah, for both. Yeah.
so what do you think maximum velocity means?
Like when it's going downhill, like
So that's a good way to explain when is it velocity changing. But I'm just asking you, what do you think velocity is?
the speed,
So what does maximum velocity mean then?
like the top speed.
Okay. So when you're on your roller coaster, Viviana, where on the ride does it have are you going the absolute fastest?
The when you're going downhill, like in the middle of the hill.
So
Or, like not the middle of downhill.
Okay, so when you're going downhill, your kinetic energy is definitely very high. So the thing is, at what point on the downhill are you going the absolute fastest? Because remember, as you're going down the hill, you're speeding up. So at which point on the hill are you going your absolute fastest?
The bottom?
The bottom of the hill, right? So the thing is, when you're at the middle of the hill, you're actually still going to be speeding up as you go down. So the absolute fastest you can be is at the very bottom of the hill.
Oh.
And so that should help you figure out the rest of the questions. I think one of them will ask you what the potential energy is. So what is the potential energy when you're at the very bottom of the hill?
Wouldn't it be with the potential? Wouldn't it, because half and half is when it's in the middle of the downhill, right?
So what about the very bottom?
I think kinetic energy would have more. Oh, potential energy would have more than kinetic energy because it starts slowing down afterwards.
Okay, no, so I like where you are in terms of on the right track. So your potential energy relates to how much energy your roller coaster has because it's above the ground. So when you're on the ground, right? So when you're on the bottom of the hill, how high are you above the ground?
0, because you're on the bottom.
So the thing is, when you're on the very bottom of the hill, your height is 0. So how much potential energy do you have if you're at the very bottom of the hill?
Oh, so would it be 0 or no?
It would be 0. So why would it be 0?
Oh yeah.
Why would it be 0?
Because you would have to multiply MGH, and if one of them is 0, then potential energy is 0.
You're correct. Absolutely love it. Okay, so now we start to get a good grasp on how we find potential energy. So the harder part is going to figure out how much kinetic energy we have. So
wouldn't it be 1 million? Because you would subtract the total by PE, and that would get you TE.
Exactly.
Okay.
Perfect.
All right. Thank you.
Perfect. Okay. Love it.